Ice is made from water, so why doesn't it sink in it? Think about it for a moment. When you drop a rock into water, it sinks. A coin sinks. A piece of metal sinks. Almost everything heavier than water disappears beneath the surface. But ice, which is literally frozen water, somehow floats on top of the very thing it's made from. It's a strange contradiction. If ice is just water in a colder form, shouldn't it behave the same way? And yet every winter, lakes freeze from the top down instead of the bottom up. Icebergs drift across oceans instead of sinking into the depths. That small, simple mystery hides one of the most important and unusual properties in all of nature. Here on Simple Things, Why and How, we explore the hidden science behind everyday mysteries that most of us never stop to question. And today, we're uncovering why something as simple as ice floating on water is actually one of the most extraordinary quirks of physics on Earth. Most substances behave in a predictable way when they cool down. As temperature drops, molecules slow down and move closer together. The material becomes denser, tighter, and heavier for its size. That's why solid objects usually sink in their liquid form. But water refuses to follow that rule. As liquid water cools, its molecules do move closer together at first. But when the temperature drops to about 4 degrees Celsius, something unusual begins to happen. Instead of packing tighter, the molecules begin arranging themselves into a structured pattern, a pattern shaped by a special kind of attraction called hydrogen bonding. These bonds pull water molecules into a delicate crystal structure as the liquid freezes. When water turns into ice, the molecules form an open hexagonal lattice, almost like a tiny three-dimensional snowflake structure. And that structure contains something surprising: space. Lots of it. Instead of being packed tightly together, the molecules are locked into positions that hold them slightly farther apart than they were in liquid form. That means frozen water actually occupies more volume than liquid water. And when something spreads out like that while keeping the same mass, its density decreases. Floating or sinking depends on a simple rule in physics known as density. Objects that are less dense than the liquid around them float. Objects that are more dense sink. Because ice has that spacious crystal structure, it becomes less dense than liquid water. So instead of falling beneath the surface, it rises above it. That's why ice cubes float in your drink, and why massive icebergs drift across the ocean with most of their mass hidden underwater. This strange property of water does something incredibly important for life on Earth. Because ice floats, lakes and oceans freeze from the top down. That floating layer of ice forms a natural blanket that insulates the water below, protecting fish and other aquatic life from freezing solid during winter. If ice behaved like most solids and sank instead, bodies of water would freeze from the bottom up, eventually turning entire lakes and oceans into solid blocks of ice. Life as we know it might never have survived. So the next time you watch an ice cube bob gently in a glass of water, remember that you're witnessing something incredibly rare in nature. A substance whose solid form is lighter than its liquid form. A small molecular quirk that protects ecosystems, shapes polar landscapes, and quietly supports life across the planet. Sometimes the survival of entire worlds depends on something as simple and as strange as a floating cube of ice. If you enjoyed uncovering the hidden science behind something as simple as ice floating, give this video a like so more curious minds can discover it. Share it with someone who loves learning how the world really works. And subscribe to Simple Things, Why and How for more fascinating mysteries explained in a simple way. Because the more we explore the ordinary, the more extraordinary it becomes.